Hello everyone, welcome to this video, and today they're going to discuss the central processing unit and memory. How do they work, what are they consist of, and how do they interact? The hardware which defines the work of the whole computer is basically the central processing unit and memory. The central processing unit and memory work together to run programs. Central processing unit, or abbreviated CPU, executes programs using fetch, decode, execute cycles, while memory stores all the programs which are being executed. A lot of modern computers, along with CPU, have graphic processing units for images. Graphic processing units can be 10 times faster than CPUs, so they can produce high-quality 3D graphics for video games or films. The speed of the whole system depends on the speed of each device, so if the speed of any device is significantly low, then the speed of the whole system will be slowed down. Now we can have a look at very simplified model of CPU, buses and memory. As we can see that buses connect memory with CPU, we can see that CPU has other devices inside itself, and we can also see that memory is divided by the line. So I hope my colleagues will explain it later, but now let's move to the next part, is key factors which affects the work of CPU. The first of these factors is the amount of cores. Core is presented by arithmetical and logical unit. As it follows from its name, it can do basic arithmetic and logical tasks. Control unit, which fetch information from memory, decode it, and then direct data flow, and registers, quickly accessible storages, which locates on CPU. And computer can have a different amount of cores. It can be 2 cores, then it will be called dual core CPU, or 4, then it will be called quad core CPU, and etc. So the more cores computer has, the more operations it will be able to do simultaneously, therefore it will speed up the work of computer. Now we move on to the second factor. It is clock speed, or it can also be referred as to clock rate. It indicates the amount of operations the computer is able to do a second. It can be measured in megahertz or gigahertz. For example, if we have a 2 gigahertz CPU, it will mean that the CPU is able to do 2 billion operations a second. The next factor is cache. Cache is relatively small storage. It locates sometimes on CPU, sometimes on a data bus, and it stores information which is more frequently used in computer, so it helps to optimize the work of computer, because computer don't have to go all the way to RAM, and it can faster get information from cache. And the last one, but not the least factor, is the type of the processor. There are 2 types of the processor. It's a complex instruction set computing and reduced instruction set computing, therefore RISC. The difference is that RISC is way smaller than CISC and operating at lower speed, so it's usually used in smartphones or tablets, while CISC is more complex. It can do more variable operations, and it is used in computers like laptops or desktops.
Hello, this is lesson about motherboard, buses, and the memory. Motherboard? What is motherboard? At first, motherboard is a circuit that connects CPU to memory or our devices. As you see on this second picture, there are small lines, and they are called buses. Bus connects CPU to our components of motherboard, and it moves instructions or data across motherboard. They are limited by their width in bits, so 32-bit bus can only move 32 bits at once. CPU cores share level 2 and 3 cache across the system bus. System bus is the bus which connects CPU to the memory, and they will usually connect to the level 2 cache through the backside bus. The backside bus is much faster than frontside bus, the FSB, and the FSB contains two types of buses. This is address bus, which sends information about where data needs to go by sending it to CPU or to RAM, and data bus sends data or receive it from memory. Bridges manage how data instructions transfer between all devices. Many PC motherboards use a NOR bridge and SOW bridge. As we see, this is NOR bridge and this is SOW bridge. The NOR bridge connects RAM, connects CPU, and connects GPU. Then the SOW bridge is a separate chip which connects smaller devices such as USB, audio, and Ethernet. Now we talk about memory. Memory provides the CPU with its instructions. There are different types of memory, such as storage or just memory, and each one plays important role in PC. Memory can be volatile and non-volatile. You see, RAM is volatile, and ROM memory is non-volatile. Volatile memory only stores information to run programs while the PC is on, but the non-volatile memory saves it. It is the opposite. Storage memory and ROM memory are non-volatile. RAM memory is volatile. And the last piece, it's a group called primary memory. There are also secondary memory, but now we talk about primary. Primary memory includes registers, some cache, RAM memory, and virtual memory. Virtual memory is always in process in PC. The closer the component is to the CPU, the quicker it brings information or receives it to execute a program. Latency or delay is the time the component takes to respond information to execute program, or just bring it to the CPU. There will be always a short delay, even a few milliseconds, between asking a computer to execute a program. Some instructions are copied into the cache to make them quicker available to execute. This is it. So we talked about motherboard, buses, bridges, and the memory. Now, Alisa.
Hi, I'm going to tell you about RAM, ROM, and virtual memory. RAM is the main place for storing instructions and data whilst a program is being executed. It is also called main memory. Program data is copied into RAM before the CPU can run the program. RAM is usually measured in gigabytes. The more gigabytes of RAM a computer has, the more programs and operations it can handle at the same time. Each unique memory location in RAM holds one word of information. Every memory location has a unique address so that once data has been stored there, it can be found again later when it's needed. RAM also has a word size, measured in bits, to indicate the size of the memory location. So the word size of the machine is how many bits its CPU can manipulate in one go. The amount of data that a CPU can manipulate with one machine code instruction or transfer over a bus is measured in bits. Increasing the word size means more data can be manipulated at a greater speed. It also means that the CPU can keep track of a larger range of memory locations. There are two types of RAM, dynamic RAM and static RAM. Dynamic RAM uses a transistor and a capacitor to represent and store a bit of data. The charge needs to be refreshed every few seconds. Static RAM uses a group of transistors combined for each bit of data. They do not lose the charge while in use. RAM technology can be non-volatile when used for flash memory in storage and ROM. Dynamic RAM is usually used for the main RAM memory. Static RAM is used for cache memory. Static RAM is more complex to build and much more expensive than dynamic RAM. Now let's move on to virtual memory. Virtual memory is a section of volatile memory created temporarily on the storage drive. It is created when a computer is running many processes at once and RAM is running low. The operating system makes part of the storage drive available to use as RAM. Virtual memory is much slower than main memory because processing power is being taken up by moving data around, rather than just executing instructions. Now let's talk about ROM, which is also known as read-only memory. Originally, its contents were static. It means that they could be only read and couldn't be changed. But there are some flash upgrades. ROM is non-volatile. It means that it doesn't lose its contents if power is lost. Read-only memory stores the basic input and output system. It is a small program that allows the computer to know what to do to find the operating system to boot the computer after the power is restored.